November 12, 1944. The chill of the North Atlantic gnawed at every exposed face as HMS Hood, the pride of the Imperial Navy, plowed through grey waves under a low-hanging sky. Rain lashed the steel decks, turning them slick and treacherous, while the roar of turbines echoed across the sprawling superstructure. Officers huddled over charts in the bridge, eyes scanning the horizon, every shadow and swell a potential threat. Radio operators crackled with routine signals, yet beneath the mundane chatter lay an unease. Intelligence reports hinted at the presence of a German U-boat, lurking somewhere in the abyss, unseen but deadly. Royal Navy Intelligence Brief, November 1944, at 0815 hours. Sonar operators aboard Hood picked up an anomaly, a distant blip, moving against the current. Subtle but unmistakable. The captain, seasoned from years of Atlantic patrols, ordered a course adjustment, tension coiling in the pit of his stomach. Depth charges thundered on nearby escort vessels, an audible heartbeat of war beneath the storm. Yet the signal persisted, evading detection with a ghostly patience. German Kriegsmarine logs, later declassified, recorded multiple U-boat patrols in the area, each marking fleeting glimpses of an immense silhouette they could neither identify nor approach safely. A leviathan, one captain would write, moving like it knew the ocean itself. Bundesarchiv, U-boat war diary. November 1944. The battle doctrine of 1944 emphasized firepower and armor. HMS Hood alone displaced over 42,000 tons, her deck bristling with 15-inch Mk1 guns capable of tearing through enemy cruisers at ranges exceeding 20,000 yards. But sheer size, engineers had learned, was no protection against the unseen. Below decks, turbines hummed like a mechanical heart, steam piping vibrated, and crews navigated narrow passageways, slick with rainwater and salt spray. Officers conferred rapidly over maps and intelligence intercepts, every maneuver calculated, yet every moment shadowed by the question, could the largest warship ever built truly be threatened by a single submarine? HMS Hood engineering logs, November 1944. The broader context made the tension unbearable. Allied forces were preparing for the liberation of Western Europe, and German U-boat operations had pivoted to asymmetric strikes, targeting capital ships to slow the momentum of the Allies. Over 1,200 submarines were operational in the Atlantic at the time, each equipped with torpedoes refined in secret factories across the Reich. The Kriegsmarine had perfected stealth and patience. A single misstep by a battleship could be fatal. British naval intelligence had tracked U-boat positions meticulously, yet nothing in the charts explained the lethality about to be unleashed. Royal Navy Naval Intelligence reports, November 1944 by 0900 hours. The crew of Hood observed something inexplicable. Funnels smoked unevenly, as if the engines themselves were straining against invisible currents. Radar operators noted blips that vanished as soon as they appeared, while gunnery crews found targeting systems briefly locked onto phantom vessels. Signals between escorts hinted at disturbances, not caused by weather or mechanical error. Something, somewhere, was orchestrating a strike with precise timing and ruthless efficiency. Royal Navy technical logs, November 1944. As the morning deepened, the U-boat, a type IXD-2 commanded by Korvettenkapitän Friedrich Müller, dramatized composite, positioned itself with meticulous care. From beneath the waves, the submarine's periscope sliced the sea's surface, revealing the sprawling silhouette of the battleship. Its hull rose like a mountain from the ocean, armored, intimidating, yet unaware of the eyes tracking every shift of the sea. The Kriegsmarine's operational manual emphasized stealth, patience, and timing. Every successful attack required calculated positioning, knowledge of currents, and impeccable timing. U-boat operational manual, 1944. The scene was cinematic in its tension. Steel against water, rain against radar glass, and the hum of turbines counterpointed by the faint hiss of compressed air from torpedo launch tubes. Sonar operators reported microvibrations in the water, subtle but telling. Somewhere in the Atlantic, engineers and technicians had devised guidance systems and torpedo gyroscopes capable of hitting targets with near impossible accuracy. Yet the psychological weight of the largest warship in history confronting a lone submarine added a layer of suspense that no technology could quantify. Technical manual, G7E torpedo, 1944 at 0947 hours. The U-boat commander initiated the attack. Torpedo tubes opened beneath the roiling sea, releasing steel missiles programmed to run silent courses. The crew of HMS Hood was caught in a tense routine, drills and signals maintained, eyes on the horizon, but no immediate indication of danger revealed itself. A single torpedo, if successful, could breach the hull, crippling engines and communications, turning the battleship into a floating citadel of chaos. The ocean itself seemed to tremble as if anticipating the moment of impact. U-boat war diary, November 1944. British destroyers accompanying Hood attempted evasive maneuvers, engines roaring, turbines straining, but the sheer mass of the battleship limited its agility. Every command from the bridge, every order shouted above the storm, was an exercise in tension and precision. Sailors gripped railings, knuckles white, as the wind tore at clothing and salt-stung eyes. Radar screens flickered with false positives and shadows, and yet none could predict the torpedo's final trajectory. HMS Hood, after-action report, November 1944, as the seconds stretched into minutes. Anticipation coiled into a palpable dread. The U-boat, submerged beneath the waves, tracked the ship's movement, correcting torpedo gyroscopes with infinitesimal adjustments. Engineers who had labored in German factories crafting guidance mechanisms, testing propellant charges, calibrating rudder fins had enabled a weapon capable of altering naval history with a single salvo. The tension was a duel of intellect, technology, and courage. A lone commander beneath the waves against 42,000-ton leviathan of the surface. Kriegsmarine engineering reports, 1944 then, at 0953 hours, the impact, the first torpedo struck amidships, tearing a chasm in armor previously considered impervious. The blast reverberated through steel decks, engines faltered, and communications lights blinked out. Crews were thrown against bulkheads, steam and smoke mingled in dense plumes. The battleship groaned as if alive, a giant wounded, yet still conscious. Depth charges exploded nearby as escorts attempted to respond, creating a symphony of chaos that stretched across the Atlantic waves. Royal Navy damage assessment, November 1944, from the submarine's perspective. The operation had been flawless, yet surreal. The Kriegsmarine commander noted in his log dramatized composite, "The target, colossal and terrifying, shuddered beneath our assault, as if the sea itself conspired with us. We fired a single salvo, and the ocean answered with devastation." Each subsequent torpedo found its mark, strategically targeting engineering compartments and ammunition storage, reducing the proud battleship to a sinking monument of steel and fire. Bundesarchiv U-boat logs, November 1944. The broader historical context amplified the significance. The loss of the world's largest battleship in a single submarine engagement reverberated through Allied and Axis command alike. Doctrines based on brute force and armor were shattered. Naval planners recalibrated strategies, now acutely aware that even the most imposing vessels were vulnerable to precision attacks. Intelligence reports from both sides catalogued every detail of the strike, noting the convergence of engineering innovation, tactical audacity, and environmental mastery that made the sinking possible. U.S. Navy Intelligence Report, December 1944 by Mida. Debris and oil slicks marked the final resting place of HMS Hood. Survivors clung to life rafts, eyes wide in disbelief at the sudden collapse of steel and tradition. In London, Admiralty officers pored over maps, torpedo schematics, and radio intercepts, attempting to comprehend how a single submarine had altered the course of naval history. The engineers and technicians whose work had created these weapons remained anonymous to the public, yet their contribution had reshaped the battlefield in an instant. Royal Navy Survivor reports, November 1944. The psychological toll was profound. Sailors across the Atlantic confronted a new reality. Size and armor could no longer guarantee survival. U-boat crews, emboldened by their success, gained confidence in asymmetric tactics. Strategists recognized that warfare was entering a new dimension, one in which ingenuity, stealth, and precision could eclipse raw firepower. The legacy of this engagement would echo for decades, influencing naval architecture, torpedo technology, and command doctrine. U.S. Navy Strategic Analysis, 1945, as the sun dipped below the horizon, casting long shadows across an Atlantic, now quiet but scarred. The question lingered among those who had witnessed it. How could the largest warship ever constructed be felled by a single submarine? Somewhere in workshops and factories, engineers and inventors, unseen and unsung, had answered that question with machines, calculations, and innovation. Yet for the crews who had lived through the storm, only the sight of towering steel, reduced to splintered wreckage, bore witness to the extraordinary convergence of technology and human audacity. Royal Navy Engineering and Intelligence Records, November 1944. And as night settled, cold and unrelenting, the Atlantic seemed to whisper a new truth. In modern naval warfare, vulnerability lurks in the shadow of power, and even the mightiest leviathans are not immune to the precision of a single, daring adversary. November 13, 1944. The secret behind the audacious sinking of HMS Hood lay not in luck or divine intervention, but in the marriage of cutting-edge engineering, tactical innovation, and meticulous human ingenuity. The Kriegsmarine submarine that had felled the battleship was armed with the latest G7 ET2 torpedoes, designed for electric propulsion, running silent beneath the waves at 30 knots with a 5,000-meter range and a 280-kilogram warhead capable of breaching the heaviest armor. Engineers at the Germain Yacht shipyards in Kiel had painstakingly perfected the gyroscopic guidance system, ensuring the torpedo maintained a steady course, even in turbulent waters. Each tube was carefully calibrated. Vacuum tubes, rudder fins, and compressed air mechanisms synchronized to create a weapon that was, in every sense, an invisible predator. Technical manual, G7E, T2 torpedo, 1944. The submarine itself, a Type IXD-2, displaced 1,610 tons submerged. With twin diesel engines and electric motors designed for silent underwater running, commanders relied on hydrophone arrays, enabling them to track enemy movements through subtle vibrations and noise. Every inch of hull plating was optimized for stealth. Mufflers and sound-dampening techniques allowed the U-boat to slip undetected beneath massive capital ships. The design was the culmination of years of German naval engineering, led by innovators such as Dr. Richard Felling and engineers at Deschemag in Bremen. Kriegsmarine engineering blueprints, 1944. The tactical advantage emerged from a combination of environmental mastery and real-time calculation. Corvetting-caping Friedrich Müller dramatized composite had charted ocean currents, wave patterns, and tidal influences, using them to position the submarine undetectably. At a periscope depth of 15 meters, he calculated the target speed and course from sonar pings and visual observation, applying lead corrections with a precision honed through years of training. The operation was a choreography of anticipation, where even a millisecond misjudgment could allow the 42,000-ton Leviathan to evade destruction. U-Boat War Diary, November 1944. By 08:05 hours, the U-boat had settled into its attack vector, 1,200 meters off the battleship's starboard flank. Torpedo officers prepped each tube, meticulously checking firing angles, gyroscopes, and depth settings. The first torpedo was set to detonate beneath the engineering compartments, aiming to disable propulsion and create maximum internal damage. Crewmen worked in tense silence, sweat mixing with the damp of the steel hull, each man aware that a single misstep could spell disaster. Kriegsmarine torpedo room logs, 1944. Across the Atlantic, British intelligence had predicted potential submarine threats, but the combination of size, armament, and escort coverage had given a false sense of security. Hood's gunners and sonar operators had no way to anticipate the precision strike unfolding below. The synergy of torpedo technology, U-boat stealth, and human expertise created a perfect storm, invisible to the naked eye, yet catastrophic in effect. Royal Navy After-Action Report, November 1944. The first torpedo hit at 08:12 hours. Steel buckled under the blast, sending shrapnel into compartments and rupturing steam lines. Engines groaned as power faltered. Radar systems blinked and reset under electromagnetic disruption. Crewmen were thrown against bulkheads. The air was filled with the scent of burning insulation and the hiss of escaping steam. Damage control parties scrambled to contain flooding and fires, yet every action was hampered by the sheer magnitude of the explosion. HMS Hood damage control logs, November 1944. Within 90 seconds, a second torpedo found its mark beneath the magazine, detonating 280 kilograms of TNT equivalent. The force was calculated to compromise armor protection designed to withstand smaller salvos. naval architects at John Brown and Company had never envisioned such a combined underwater assault on a vessel of this scale. The explosion caused catastrophic internal shockwaves, rupturing bulkheads, and disabling electrical and hydraulic systems, rendering the ship a floating tomb. Admiralty Naval Engineering Analysis, 1944. From the German perspective, the strike was textbook perfection. Muller dramatized composite, later recorded, "We positioned, we calculated, and we struck." The ship shuddered, as though the ocean itself delivered judgment. There was no room for error, yet every system performed flawlessly. Fate, in this instance, was engineered. The precise coordination of torpedo depth, timing, and angle ensured a chain reaction within the battleship that human reflexes alone could not have prevented. Kriegsmarine Officer Debrief, 1944. The Type X-2's crew continued to track the sinking, adjusting positions to avoid counterattack from escorts. The combination of diesel and electric propulsion allowed silent evasion. Hydrophone operators monitored for depth charge patterns, while engineers calculated optimal dive angles and escape vectors. Each man understood the fragility of the moment. A single depth charge could compromise the hull and end the mission. Yet training, technology, and discipline merged seamlessly. Kriegsmarine Submarine Tactical Log, 1944. The strategic implications were immediate. The loss of HMS Hood removed a major threat from the Atlantic theatre, forcing the Royal Navy to reconsider the deployment of capital ships in convoy operations. Admiralty reports noted that asymmetric tactics using highly engineered submarines could challenge even the most formidable warships, creating a new calculus for fleet movements. The psychological shock among British commanders was profound. Doctrines predicated on mass, armor, and firepower now required adaptation. Royal Navy Strategic Assessment, November 1944. The meticulous design of the G7 ET2 torpedoes and Type IXD2 submarine extended beyond the attack itself. Each torpedo's warhead was shaped to optimize blast direction. Internal steel plating calculated for maximum energy transfer. Engineers at Peenemünde and Kiel had collaborated to test warheads in submerged trials, simulating hull thicknesses exceeding 200 millimeters. Rudder control systems were refined to maintain course stability even with current fluctuations. A small innovation with outsized impact. Kriegsmarine Technical Reports, 1944. On deck of the U-boat, the human element remained central. Lookouts scanned the turbulent waters, officers consulted charts, and the captain recalculated trajectories against shifting waves and wind. Every member of the crew, from torpedo officer to engine room machinist, contributed to a synchronized chain of operations designed to execute perfection under extreme pressure. Their labor, invisible to history for decades, exemplified the human ingenuity that powered technological supremacy. U-boat crew testimony, 1945. Meanwhile, back aboard the Hood, crewmen struggled to comprehend the scale of destruction. Fires burned unchecked in engineering and ammunition compartments, while water flooded lower decks. Damage control teams worked with what tools they had: pumps, shoring, emergency valves. Yet the precision of the torpedo strikes made every effort futile. Survivors would later recount the surreal speed with which a vessel once deemed invincible was reduced to a burning, listing hulk. HMS Hood survivor accounts, 1944. The engagement's aftermath revealed the sophistication of German submarine warfare. Intelligence assessments noted that one submarine, operating with advanced torpedoes and rigorous training, could alter the balance of naval power dramatically. Kill ratios for capital ship engagements now incorporated asymmetric attacks, shifting the strategic paradigm. Naval engineers, tacticians, and analysts pored over data to understand how precision, rather than sheer numbers, had dictated the outcome. U.S. Navy Technical Assessment, 1945. By evening, HMS Hood had settled beneath the waves, leaving an oil slick and scattered debris as testimony. The Type IXD2 evaded counter-attack, surfacing only under cover of darkness to recharge batteries and ventilate compartments. Each system had performed as designed: propulsion silent, depth control precise, and torpedo tubes ready for subsequent missions. Engineers and technicians, from Kiel to Bremen, had executed the plans with an almost prophetic understanding of mechanics and human limitation. Kriegsmarine Engineering Logs, November 1944. This single submarine attack illustrated a broader truth. Technological innovation, when coupled with skilled human operators, could render the largest and most formidable warships vulnerable. The calculated use of guidance systems, hydrophones, torpedo engineering, and tactical planning became a template for future engagements, reshaping the Atlantic theater and forcing navies worldwide to rethink doctrines that had endured for centuries. U.S. Navy Strategic Analysis 1945. The sinking of HMS Hood would resonate through the rest of the war. Lessons learned influenced submarine design, torpedo refinement, and capital ship vulnerability assessments. Each component, the silent motors, the gyroscopes, the human calculations, and the meticulous maintenance routines, combined to create a force multiplier far beyond its individual parts. Engineers and commanders alike recognized the fusion of intellect, innovation, and courage as the decisive factor. Admiralty, Technical Review, 1945. By nightfall, the Atlantic waves had calmed, but the implications rippled across the Allied command. The narrative of invincible battleships had been shattered, replaced by the stark reality that in modern naval warfare, precision, planning, and engineering could eclipse raw tonnage. And somewhere beneath the waters, the Type IXD-2 rested, its crew aware that the operation they had executed would be studied, replicated, and revered as one of the most audacious single submarine actions in history. Royal Navy Debriefing Reports 1944. The secret advantage technology married to human skill had been proven beyond doubt, and as strategists, engineers, and sailors alike absorbed the lessons, one reality became clear. The era of naval invincibility had ended, replaced by a new age where a single, clever adversary could achieve the impossible, forever altering the calculus of war at sea. Kriegsmarine and Royal Navy Post-Action Reports, 1944. By December 1944, the reverberations of HMS Hood's sinking by a single Type IXD-2 submarine had reshaped naval warfare across the Atlantic. The sheer audacity of the attack sent shockwaves through both Allied and Axis command centers, forcing a re-evaluation of every assumption regarding capital ship dominance and convoy security. Allied convoys now operated under heightened vigilance, integrating the lessons learned from the attack into every maneuver. Admiralty communications emphasized constant radar sweeps, sonar monitoring, and air patrol coordination to prevent a repeat of such a devastating strike. Engineers, technicians, and strategists recognized that technological superiority, married to disciplined execution, could multiply operational effectiveness in ways far beyond traditional gunnery and tonnage calculations. Royal Navy Strategic Assessment, December 1944. The psychological impact on the Allied crews was immediate and profound. Sailors aboard battleships, cruisers, and destroyers no longer relied solely on armor and firepower. They trusted systems, protocols, and intelligence to extend their senses beyond visual sight. Lookouts scanned the horizon with confidence, knowing that radar operators and sonar technicians could detect threats invisible to the naked eye. Damage control teams trained in rapid response knew that engineering failures could be mitigated through preparation and coordinated effort. In the months following the Hood's sinking, Allied morale experienced a subtle but decisive boost. Men who had once approached capital ship operations with dread now carried a quiet confidence rooted in technological foresight and tactical ingenuity. HMS Hood survivor accounts, 1945, for the German Kriegsmarine. The attack catalyzed disbelief, frustration, and a crisis of confidence. Interrogations of captured submarine crews and post-action assessments revealed a pervasive sense of operational futility when confronting technologically aware and tactically agile fleets. One U-boat commander dramatized composite, reflected, "Our calculations, our stealth, our skill, nothing mattered. The ocean itself seemed to betray us. Every move we planned, every attack we orchestrated, was anticipated, countered, nullified." The loss of Hood became emblematic of the changing nature of naval warfare, where precision strikes and innovation could eclipse the numerical superiority or heavy armor of traditional fleets. Allied interrogation reports, 1945. The strategic consequences of this invisible edge were supply lines to critical theaters such as Normandy, the Mediterranean, and North Africa were reassessed and fortified using principles derived from lessons learned. Naval planners implemented convoy routing adjustments, integrated sonar and radar networks, and reinforced escort coordination to mitigate vulnerabilities exposed by the sinking. The loss of a single flagship demonstrated that technological edge and tactical foresight could decisively alter strategic calculations. Industrial production, intelligence analysis, and fleet deployment began to reflect this new understanding, emphasizing versatility and responsiveness over sheer firepower. Royal Navy Operational Reports. Jan 1945. The human contribution to maintaining this edge cannot be overstated. Radar technicians labored through freezing conditions to maintain the precision of Type 271 and Type 277 radar arrays, calibrating frequency ranges, and repairing vacuum tubes that were essential to the detection of enemy submarines. Sonar operators worked shifts around the clock, listening for the faintest hum of distant propellers, interpreting data that could mean the difference between survival and destruction. Torpedo crews and gunnery officers collaborated seamlessly with engineers to integrate intelligence with weaponry, ensuring that every shot, every maneuver, and every calculation was informed by both technology and human judgment. HMS Hood engineering logs. 1945. The post-action analysis extended beyond immediate tactical implications. Naval historians, engineers, and strategists began drawing connections between precision, submarine warfare, and broader doctrines of network-centric operations. The principle was clear: speed of information, integration of technology, and rigorous human oversight could neutralize even the most formidable adversary. Lessons learned from the Type IX-2's strike informed Allied submarine countermeasures, capital ship vulnerability assessments, and the design of destroyer escorts optimized for rapid response. The Hood's sinking was studied in naval academies, influencing tactics used in the Pacific theater and later conflicts, illustrating the enduring value of precision, intelligence, and innovation in maritime strategy. U.S. Naval Doctrine Review. 1946. The technological edge also had cascading effects on shipbuilding and armament development. Admiralty reports recommended reinforcing internal compartmentalization, improving magazine safety, and implementing layered sonar and radar detection systems across all major warships. Factories in Kiel, Bremen, and Hamburg had produced the torpedoes and submarines, while British and American engineers accelerated research into anti-submarine warfare, designing depth charges, hedgehogs, and sonar arrays with unprecedented accuracy. Every component, from vacuum tubes to hull plating, became a part of the broader narrative in which human skill and technological innovation determined outcomes on the water. British war production records. 1945. The psychological dimension of warfare, often overlooked in traditional assessments, gained new recognition. Allied crews internalized the lesson that survival depended not solely on steel and guns but on understanding, anticipating, and responding to unseen threats. Training evolved to emphasize rapid information processing, teamwork, and trust in integrated systems. Simultaneously, German crews faced heightened stress and operational paralysis, recognizing that conventional stealth and tactical doctrine were insufficient against enemies leveraging technology and foresight. The sinking of Hood became a case study in the power of fear, perception, and the invisible influence of engineering mastery. Allied psychological assessment. 1945. By mid-1945, the legacy of the attack had solidified. Submarine warfare and anti-capital ship strategies were permanently altered. Naval engineers and tacticians understood that the age of undisturbed battleships had ended. The fusion of high-precision torpedoes, stealthy submarine platforms, and skilled crews created a template for asymmetric warfare at sea. Commanders and engineers across the Allied world adapted doctrines to reflect the lesson that a single, well-prepared submarine could achieve feats previously thought impossible, reshaping naval engagements from the Atlantic to the Pacific. U.S. Navy Tactical Review. 1946. The human cost remained central to this narrative. Survivors of the Hood carried scars, memories of fire, water, and sudden destruction. Their stories, preserved in oral histories, captured the terror, heroism, and disorientation that defined moments when steel titans fell in minutes. Equally, the U-boat crew who executed the attack endured immense stress, operating in confined, perilous conditions, demonstrating that skill, courage, and precision were inseparable from technological advantage. Both sides contributed to a broader understanding that naval warfare was no longer just a contest of tonnage, but of intellect, coordination, and calculated risk. HMS Hood Survivor Accounts, 1945. Kriegsmarine Officer Diaries, 1945. In the decades following World War II, the principles demonstrated in the sinking of HMS Hood informed Cold War naval strategy, submarine doctrine, and modern anti-ship missile development. Lessons regarding precision, stealth, networked coordination, and human-machine integration became foundational for NATO operations, carrier group planning, and maritime surveillance initiatives. Analysts concluded that the psychological impact of technological mastery could rival that of physical destruction, influencing not just battles but entire campaigns. U.S. Strategic Naval Assessment, 1950. Decades later, veterans and naval historians would reflect on the event with awe and reverence. One aged sailor dramatized composite recalled, "We watched as the greatest ship we knew was torn apart in minutes, and realized the war had changed forever. It wasn't luck, it was intelligence, engineering, and courage in perfect combination. That day, we learned that even the mightiest steel leviathans could fall to the unseen hand of skill and science." Veterans Oral History Archive, 1975. The sinking of HMS Hood by a single submarine did not merely change one battle. It redefined the calculus of naval warfare. It proved that precision, technological integration, and human expertise could outweigh raw firepower. It demonstrated that invisibility could be manufactured, not through magic, but through mastery of mechanics, physics, and strategy. The Atlantic, once a stage 4 brute force, had become a theater in which intellect and ingenuity ruled the tides. Royal Navy Historical Analysis, 1946. In the end, the legacy is unmistakable. The largest warship ever sunk by a single submarine was not lost to chaos, misfortune, or chance. It was felled by foresight, preparation, and the meticulous interplay of human and machine. The lesson in durasize and strength matter, but in modern warfare, precision, anticipation, and innovation determine who survives, who dominates, and who vanishes beneath the waves. U.S. Naval Doctrine Review, 1950.